In this video, I'll be helping you with the ALEKS problem type called solving equations with 0, 1, or infinitely many solutions.
So we have a couple of different possibilities. First of all, if we just have one solution, it's going to look like this guy right here. We will have the variable equals some number. So I'm just going to put v equals some number. It's a normal sort of solution, what you would expect when you solve an equation. Now, our other possibilities for zero solutions, sometimes whenever you're solving these equations, the variable may cancel out altogether. So we end up with something without a variable and something that says something illogical, such as 2 equals 3. The variable has canceled out and we're left with a statement that is not true. 2 does not equal 3. So when we get that as our last step when we're solving, we know something's up there. That is no solution. The other possibility is maybe in solving the equation, we get a true statement, like 4 equals 4. Again, the variable canceled out and we're left with just something that is true. 4 equals 4. That is always true. So for those equations, any real number can be plugged in and it will work. So there are infinitely many whenever this happens. So let's try these two equations just to see what happens. Both of them have parentheses in them. The first thing I'm going to do is distribute the number outside to get rid of those parentheses. The first one here will give me a 6 times v, 6v, 6 times 1, 6, minus 9 equals, on the right-hand side, 4 times v is 4v, 4 times minus 1 is minus 4, and bring down the 2v. So we've gotten rid of the parentheses, but before we move on, we should simplify this by combining like terms. Now, on the left, this plus 6 and minus 9, those are like terms, so I'm going to combine those together. I still have the 6v on the left, but the plus 6 and the minus 9 become minus 3. On the right-hand side, I have two like terms there as well, the 4v and the 2v, even though they're not beside each other, they're on the same side of the equation, so we can add those together and get 6v minus 4. Just bringing down the minus 4. From here, if we were trying to get the v's on one side, I would have to move one of these. Let's say I move the one on the right over to the left-hand side, but that cancels the one on the right, and it also cancels the one on the left. So I'm left with minus 3 equals minus 4. And that is not a true statement. So my solution is not minus 3, and my solution is not minus 4, since my attempt to solve this equation has given me something that doesn't make any sense. It means there is no solution for this equation. And then we have a second equation here to solve as well. Same approach, I'm going to distribute to get rid of the parentheses. And when I do, 4 times 3 is 12. 4 times y is 4y, subtract that next y. And then on the right-hand side, we have the 6 brought down, the 3 is distributed, 3 times y is 3y, 3 times 2 is 6, no more parentheses, and we need to combine like terms. On the left-hand side, the 12 comes down, the 4y and the minus 1y combine to be plus 3y. On the right-hand side, the numbers 6 and 6, those are like terms, so they combine to be 12, and the 3y comes down. And if we were trying to get the y by itself on one side, I would have to move one of them. So let's say I move the one on the right, minus 3y, over to the left. Those would cancel, and I would now have 12 equals 12. So our solution is not 12. We did not get y equals 12. Our solution became 12 equals 12, which is always true. So that means we have infinitely many solutions to this equation, and all real numbers. our solutions here.